Hey everyone, and welcome to the sixth lesson in this series, where we are going to master logical functions in Excel, which are the workhorses of building powerful spreadsheets. Whether you're a beginner just getting started or an experienced user looking to refine your skills, this lesson is designed to cover everything from foundational concepts to advanced applications. Remember to download the lesson file from the link below. Practicing with this workbook is essential for fully understanding the concepts. By keeping a copy, you'll have a handy reference to tackle any complex scenario using the provided examples. Let's get started with chapter 1. Logical functions are powerful tools that help you make decisions based on specific conditions. These functions act like detectives, examining your data and returning a verdict, true or false. Let's start with the most basic logical comparisons. Are two values the same or are they different? We'll use logical operators to compare these values. Let's get started. Type in an equal sign, select the first value, type equal sign again, then select the second value. Press Ctrl Enter. This formula compares both values and returns false since 20 is not equal to 25. The double equal sign is the key here. It's the comparison operator that checks for equality. Next, let's find out the opposite. Are these values different? Type in an equal sign, select the first value. Here, we will use the not equal to operator. Select the second value, press Ctrl Enter. Since 20 is not equal to 25, the formula evaluates to true. If the values were the same, the formula would have returned false. These were the two most basic logical comparisons in Excel. Now let's put these skills to work with a practical example. This time we'll check if sales have increased from previous year for different products. Let's get started. Here we have a data set showing sales figures for different products over 2 years, 2025 and 2026. And we have a result column where we want to show a true or false value depending on the sales increase. All right, so type in an equal sign, select the cell containing 2026 sales. Now type in greater than sign and select the cell containing 2025 sales. Press Ctrl Enter. As you can see, the result for track loaders displays true because sales increased in 2026 compared to 2025. Now double click the fill handle and send it down. This is a quick way to identify which products saw an increase in sales from the previous year. Next, let's check out another simple example where we need to determine whether students have passed the exam. We have a table with student names and marks in different subjects, along with a result column where we'll use a formula. Right on top of this, we have a cell that defines the total marks required to pass, which in this case is 180. Let's get started. First, we will use the sum function to calculate the total marks acquired by students. So type in an equal sign, sum, press tab, select the range of cells containing the marks for the first line item, which is John. Now close parenthesis. Now type in the logical operators, greater than and equal to sign. This will compare the total marks with the passing marks. Finally, select the cell containing the total marks required to pass. Press F4 to lock it as we will send the formula down. Now press Ctrl Enter. Now double click the fill handle and send it down. So as you can see, this formula checks if the total marks obtained by any student is greater than or equal to the passing marks. If the total is high enough, the formula returns true for pass, otherwise it returns false for fail. So far, we have explored how to use logical comparisons for simple conditions. Now, let's get more sophisticated and see how to combine multiple conditions using the AND function. The AND function returns true only if all the conditions you specify are true. It's perfect for combining more than one logical test. We have a table with product information, including sales figures for 2025 and 2026, along with a result column where we'll use a formula. Right on top of this, we have a cell that defines the required average revenue. Our goal here is to identify products that meet two conditions. Number one, increase sales from 2025 to 2026. And number two, latest revenue figure has to surpass the last 5-year average revenue. Let's get started. Type in equal sign and press tab. Select the cell containing the 2026 sales figure. Type greater than sign and select the value under 2025. This will be our first logic. Type a comma to move to the next one. Again, select the value under 2026. Type in greater than sign and select the cell containing the last 5 years average revenue. Press F4 to lock the cell. Close parenthesis, press Ctrl Enter. Now double click the fill handle and send it down. This formula checks if a product's sales increased from 2025 to 2026 and if those sales also surpass the last 5-year average. Only if both conditions are true, the AND function returns true in the result column. Let's verify the result of the first line item. Track loaders. Sales in 2026 is more than 2025, as you can see, and this value is also greater than the average required revenue. So both conditions have been met, hence the result being displayed is true. To summarize, the AND function lets you evaluate multiple conditions and ensure all of them are met before returning true. This adds a powerful layer of control to your spreadsheets. Next, we'll determine if an employee qualifies for a bonus. We'll use two approaches to apply the AND function. First, we'll type in the values directly, and then we'll reference the cells containing the criteria so that you get a good understanding of both methods. Let's take a look at the data set first. We have a table with employee information including names, regions, sales figures, and two result columns. On top of this table, we have our criteria for qualifying for a bonus. The employee must be from the Boston region and their sales must exceed $8,500. One thing to note here is that both these cells have been named region and sales value respectively. If you look up at the name box, you'll get to see the name of the cell. We had covered this in our very first lesson under name manager. Also, when you select the sales value cell, you will notice when you look up at the formula bar that the underlying value is only the numbers. Now, if you're wondering how that is possible when you can clearly see a greater than sign in front of the numbers, then you should check out the third lesson in the series where we have covered text functions and custom number formats. All right, let's get started. First, we will type in the values. So type in equal sign and press tab. Our first condition is that the region needs to be Boston. So select the cell containing the region, type in equal sign, and then type in Boston within double quotes. Type comma to proceed to the next logic. Next, select the sales value, type in greater than sign, and 8,500. Close parenthesis, press Ctrl Enter. As you can see, this formula returns true if both conditions are met and false if either condition is not met. Next, let's reference the criteria cells directly. This approach makes our formula dynamic. So if we change the criteria, the results will update automatically. So type in an equal sign and press tab. Select the cell containing the region. Type in equal sign, region, comma. Select the cell containing sales. Type greater than sign and now type in sales value. Close parenthesis, press Control Enter. To summarize, both formulas evaluate if an employee meets both criteria for the bonus, being in the Boston region and exceeding $8,500 in sales. The first formula used typed values for comparison, while the second one uses cell references for a more flexible approach. Next, let's check out how to handle 3 or even more conditions using the AND function. In this example, we'll determine if revenue has increased year over year for several products. We have a table with product information, including sales figures for 4 years, 2024 to 2027. And we also have a result column where we'll use a formula to identify consistent revenue growth. Let's get started. Type in an equal sign and press tab. First, we'll check if sales in 2025 were more than in 2024. So select the cell containing 2025 sales, type in greater than sign, then select the cell containing 2024 sales. Type a comma to move to the next logic. Now we'll check if sales in 2026 were more than 2025, comma. Finally, we'll check if sales in 2027 were more than 2026. Close parenthesis, Control Enter. Double click the fill handle and send it down. The AND function can handle any number of conditions as long as all of them evaluate to true for the overall result to be true. Now let's verify the result of the first line item. As you can see, the result is true because the revenue of track loaders has increased every year from 2024 to 2027. To summarize, this formula checks if a product's revenue increased year over year across all 3 comparisons. Only if all 3 conditions are true will the formula return true in the result column. Next, we'll explore the OR and NOT functions to determine if a review is required for loan approval based on credit rating and last year's revenue. Here, we have a sample data set for a loan department. We need to determine if an organization requires a review based on their credit rating and last year's sales. An applicant qualifies for automatic loan approval if they meet at least one of these criteria. Required credit rating of 3 or higher, last year's revenue of $10,000 or more. We have a table with loan applicant information, including credit rating, last year's sales, and a is review required column or result column where we'll use the formula. The OR function in Excel is a logical function that returns true if any of the conditions you specify are true. It's useful when approval hinges on meeting at least one requirement. All right, let's get started. Type in equal sign or press tab. Under the Under the first logic, select the cell containing the credit rating, type in greater than and equal sign. Now select the cell containing the required credit rating. Now press F4 to lock it. As you can see, this is not a named range or a named cell. Type a comma to proceed to the next logic. Now select the cell containing the last year's sales. Type in greater than an equal sign. Now select the cell containing the minimum required revenue. Now press F4 to lock it. Close parenthesis, Control, Enter. Let's verify the result of the first line item. Credit rating is below 3, but last year's sales are above $10,000. The OR function here checks if this applicant meets at least one of the approval criteria and returns true. But we need to reverse this to show false, as review is not required for this applicant, as one of the conditions have been met. So here, we'll wrap the OR function within the NOT function, which reverses the logical outcome of another function or comparison. So double click the cell. Just before the OR function, we will type in NOT, press tab, close parenthesis for the NOT function, and press Control, Enter. As you can see, the NOT function has flipped the result from true to false. Applicants with a credit rating of 3 or higher, or with last year's sales of $10,000 or more, show false. All others show true, indicating they need a manual review. To summarize, we use the OR function to check if either the credit rating or last year's sales met the criteria for loan approval. The NOT function was used to reverse the result, indicating if a review is required. These steps can be easily replicated to create efficient rules for loan approvals or other decision-making processes in your spreadsheets. Now let's proceed to the next chapter. In this chapter, we learn about one of the most used functions in Excel, the if function, which is critical for decision making. The if function allows you to create conditional statements. It checks a condition and returns a specific value if the condition is true, and a different value if it's false. We'll start with a simple example to determine if a student passes or fails based on their score. Let's get started. We have a data set here with student scores and a result column where we'll use a formula to determine pass or fail based on a passing score of 50. Alright, so type in equal sign if, press tab. This function takes 3 arguments. First, under logical test, we need to make the logical comparison, which in this case is finding out whether this score is more than or equal to 50. So select the cell containing the score, type in greater than sign, an equal sign. Now type in 50. Type comma, proceed to the next part. Now, based on this result, the if statement can have 2 results. The first result is if your comparison is true. The second, if your comparison is false. So under value if true, type in pass within double quotes. Type a comma to proceed to the last part. Under value if false, type in fail within double quotes. Close parenthesis, press Control Enter. So as you can see, this formula checks if the score is greater than 50. If it is, the result is pass, otherwise it's fail. Next, let's check out another interesting example using the if function. This time, we'll use it with multiple conditions to determine commission rates based on sales figures. Let's take a look at our data set first. We have a table with salesperson information, sales figures, and a commission amount column where we'll use a formula to calculate commissions based on a tiered commission rate. Sales of $6,500 or more earn a 15% commission rate, while sales below that earn a 10% commission rate. Let's get started. Type in equal sign if, press tab. Under logical test, select the cell containing the sales value. Now type in greater than and equal to sign and type in 6,500. Type comma. Now if the result is true, then we want to multiply the sales value by 15%. Or else we want to multiply the sales value by 10%. Close parenthesis, press Control Enter. Let's verify the result of the first line item. The sales value is more than 6,500, so the commission rate is 15%. So let's check this. As you can see, the result is correct. And that's how you can use the if function to calculate commission amounts based on sales values. This method helps ensure that each salesperson receives the correct commission based on their performance. Next, we'll combine the if function with the ISBLANK function to determine bonus eligibility based on extra sales figures. Let's take a look at our dataset first. We have a table with salesperson information, extra sales figures, which can be 0, and a bonus amount column, where we'll use a formula to calculate the bonus amount based on extra sales. Salespeople with extra sales figures, excluding 0, receive a 7% bonus on the extra sales amount. Otherwise, they receive no bonus. Let's get started. Type in equal sign if, press tab. Under logical test, type is blank, which checks if a cell is empty. Under value, select the cell containing extra sales. Close parenthesis. Now, we will wrap this inside the NOT function to flip the result, as we want our calculation formula under value if true. So type in NOT right before the isBlank function, press tab, and now close the NOT function. This will flip the result of the isBlank function. Type a comma to proceed to the next part. Under value if true, select extra sales and multiply it by the bonus percent. Now press F4 to lock it. Comma. Now under value if false, type no bonus within double quotes. Now close parenthesis for the if function. Press Control Enter. We want our values to have dollar signs in front of them, and also we don't need any decimals. So we will wrap the bonus calculation inside the dollar function. So type in dollar, press tab. So this will be our number. Type comma. Under decimals, type 0, close parenthesis, Control Enter. As you can see, this function checks if there's a value including 0 in the extra sales cell. If there is, a 7% bonus is calculated on the extra sales amount. If the cell is blank, no bonus is displayed. By combining if with isBlank, we can create more refined decision-making logic in our spreadsheets. This allows you to handle scenarios where a blank cell might indicate a specific condition, such as no bonus eligibility in this case. Next, let's check out a more complex example where we will combine different date and text functions to achieve our desired result. In this example, we'll explore how to create dynamic formulas that show invoices due next month. This will ensure our data remains current and automatically updates every time we open or refresh the workbook. Let's take a look at our data set first. We have a table with invoice information including due dates and a result column where we'll use a formula to identify invoices due next month. Above this table, this cell contains the today function, and as you can see, the current date is 8th July 2024, which we will use in our calculations. Our goal here is to create a formula that adjusts automatically based on the current date to identify invoices due in the upcoming month, which is August 2024 in this case. First, we need to calculate the next month of the same year based on the current date. We also need to make it dynamic so that it keeps changing. In order to achieve that, we will use the date function. So type in equals sign, date, press tab. Under year, we will use the year function. Under serial number, we will use the current date. Under month, we will use the month function. Under serial number, it will be today's date. Now close parenthesis for the month function. Now we will add 1 to month as we need the next month. Type comma. Under day, we will use the day function and serial number will be 1. Now close parenthesis for the date function. Press Ctrl Enter. This result displays the first date of the upcoming month based on the current date, which is 8th July. Now we need only the month and year for comparison. So we will wrap this inside the text function to display only abbreviated month and 4-digit year. So type in text, press tab. This will be our value, comma. Under format text, within double quotes, we will type in MMM YYYY. Close parenthesis, press Ctrl Enter. Next, we will compare this to the month and year of the due date to see if it matches. So at the end of the formula, type in an equal sign, text, press tab. Under value, select the due date, comma. Now type in the same format, MMMYYYY. Now close parenthesis for the text function. Press Ctrl Enter. As you can see, the result for the first line item is true as the month and year of this invoice date matches August 2024. Now we will wrap this entire formula inside the if function. This will be our logical test. Now type a comma. Under value if true, type in due next month. Within double quotes, comma. Under value if false, we want a blank. Close parenthesis, press Ctrl Enter. This formula dynamically calculates the beginning of the next month based on the current date and then compares it to the invoice's due date. If they match, due next month is displayed, otherwise the cell remains blank. This approach allows you to create dynamic formulas that adjust based on the current date. This is useful for various tasks, such as identifying upcoming deadlines, calculating time-based rates, or keeping track of expiration dates. Next, we learn how to use the if function combined with the or function to identify items that match one of the listed colors. Here we have a data set showing different clothing items and their colors. Our goal here is to determine if the color matches one of the specified colors which are listed in these cells. Please note that the cells containing the colors have been named. The formula we enter should check if the color is red, blue, or pink. If it is, the result should display match, otherwise X. Let's get started. First, we will use the OR function to determine if the color in this cell matches any of the listed colors. So type in equal sign or press tab. Select the cell containing the color. Type equal sign. Now select the first color in the list, comma. Now do the same for the rest of the colors. Type in an equal sign. Select the next color, comma. Now close parenthesis for the OR function. Press Ctrl Enter. If any of these comparisons are true, meaning the color matches one of the listed colors, the entire OR function returns true. As you can see, for the first line item, the result is true because red is one of the listed colors. Now, let's wrap this inside the if function to get the desired result. So type in if, press tab. The OR function will be our logical test. Type comma. Under value if true, type in match within double quotes, comma. Under value if false, type in X. Close parenthesis for the if function. Press Ctrl Enter. Excel now automatically determines if the color matches one of the specified colors for each item. As you can see, items with colors red, blue, or pink are marked as match, while all others are marked as X. Now, we can also apply conditional formatting to these cells, which will help us visually identify matching items quickly. So, select all the cells in the result column, go to the Home tab. Under Conditional Formatting, click on New Rule. Select Format only cells that contain and set the rule to format cells that contains. Here we will select equals to cell value, which equals to. Now we will mention the word match. Now click on Format, and now we will choose a fill color for the background. Click OK, then click OK again to apply the rule. Now all cells with match are highlighted in green, making it easy to see which items match our specified colors. To summarize, by combining if with or and conditional formatting, we can create clear and visually appealing ways to identify matches and exceptions in your spreadsheets. This can be adapted to various scenarios where you need to highlight specific data based on multiple conditions. Next, let's explore a complex example where we learn how to use the and or functions within the if function to check multiple conditions simultaneously. We'll use an example related to loan approval. Let's get started. Here we have a data set showing company details, including date of incorporation, total employees, and average revenue. We'll create a formula to determine whether to approve a loan or review the application based on certain conditions. A company qualifies for automatic loan approval if it meets both of these conditions. Number one, the company must be at least 10 years old from the current date. Number two, it has to meet at least one of these additional conditions, has more than 10,000 employees, and has an average revenue greater than $50,000. We can construct this complex decision-making logic by nesting an if function with and or functions within the main if statement. The nested if structure will allow us to evaluate multiple conditions sequentially following a clear hierarchy. First, let's determine one of the required conditions, the company's age in years. So type in equal sign today minus the incorporation date. Subtracting the incorporation date from today's date will give us the total difference in days. Enclose this formula within parentheses and divide it by 365, convert it to number of years. Press Ctrl Enter. Press Ctrl Shift tilde to switch the number format to general format. Now we need to check if this value is greater than 10. To do this, enclose the entire formula within parentheses again. And now type in the greater than sign and then 10. Press Ctrl Enter. This will tell us whether the required condition has been met or not. Next, let's find out whether the first applicant meets any of the additional conditions using the OR function. Select the adjacent cell, type in equal sign or press tab. Now select the cell containing total employees, type greater than sign 10,000. This checks if the number of employees is greater than 10,000. Next, select the cell containing average revenue. Type greater than sign 50,000. This checks if the average revenue is greater than $50,000. Now close parenthesis, Control Enter. As you can see, the result is true because it meets one of the conditions, which is average revenue of more than $50,000. Now we will wrap both functions inside the AND function. So let's open the clipboard pane first and now copy both functions to the clipboard pane, excluding the equal sign. Now select both cells and press delete. In the result column, type in equal sign and press tab. First, paste the function containing the required condition, which is the age requirement, comma, next. paste the OR function. Close parenthesis for the AND function. Press Ctrl Enter. As you can see, the answer is true because both functions inside the AND function have returned true. All we need to do now is wrap the AND function inside the IF function to get the desired result. So double click the cell, right before the AND function, type in if, press tab. The AND function will be our logical test. Type comma. Under value if true, type approve loan. Under value if false, type review application. Now close parenthesis, Control Enter. Now double click the file handle and send it down. As you can see, the function has returned approve loan for those applicants that have met both conditions. By combining nested if with and or, you can create formulas to handle complex decision-making logic in your spreadsheets. This allows you to evaluate multiple conditions and automate loan approvals or other scenarios requiring a multi-layered approach. Next, let's explore another complex example where we'll use the if function along with VLOOKUP and average to analyze student performance relative to the class average. Let's get started. We have a table with student names and their corresponding term 1 and term 2 scores. Our goal here is to calculate a message based on a student's performance compared to the class average in both terms. First, we'll break down the formula into smaller parts. Let's start by calculating the class average for term 1 and term 2. Type in equal sign, average, press tab, select all the cells under term 1, press Ctrl Enter. Press tab to move to the next cell. Now, press Ctrl R to copy the formula to the right. Press F2. As you can see, the range of cells is correct. And this time the average function is calculating the average for term 2. Next, we'll use VLOOKUP to look up the scores for this student name in this cell for both terms. So type in equal sign, VLOOKUP, select the cell containing the student name, comma. Now select the entire table, comma. Column index will be 2 as we want the term 1 results, comma, 0. Close parenthesis, Control Enter. Press tab to move to the next one. Now we want the same formula in this cell, but we want to look up a different column. So paste the VLOOKUP function and change the column index number to 3. Press Ctrl Enter. Next, we need to find out whether this student's score is more than the class average. To do that, we'll copy the average function for term 1 and compare it with the score of John in term 1. So double click the cell, right at the end, type in greater than sign and paste the average function. Press Ctrl Enter. This tells us whether John has scored more than the class average in term 1. Now let's do the same for term 2. Type in greater than sign, paste the average function. Press Ctrl Enter. As you can see, John has scored more than the class average in both terms. Next, we will wrap both formulas within the AND function, which will ensure that both conditions are met. So first, open the clipboard pane, clear all, and now copy both formulas to the clipboard. Now, type in equal sign and press tab. Now paste both formulas separated by a comma. Close parenthesis for the AND function. Press Ctrl Enter. Now we will use the if function to display a message based on the result of the AND function. If both scores are above the class averages, the formula should return keep it up, otherwise improvement required. So press F2, type in the if function right before the AND function, press tab. This entire formula will be our logical test. So type a comma right after that. Under value if true, type in keep it up, comma, improvement required. Close parenthesis for the if function. Press Ctrl Enter. Now remove all other formulas as we don't need them anymore. Select them all and press delete. Close the clipboard pane. And now we will change the position of the result. Let's look up a different student to see if the answer updates. Great. To summarize, this formula demonstrates how to combine different formulas to analyze student performance relative to the class average. You can adapt this logic to compare other data sets and create more complex performance evaluations. Let's proceed to the next chapter. In this chapter, we are going to dive into the IFS function, which is a powerful tool for evaluating multiple conditions and returning corresponding values. It offers a cleaner and more efficient alternative to nested if statements, especially when dealing with complex scenarios. The IFS function checks one or more conditions and returns a value based on the first true result. IFS allows up to 127 pairs of condition and value arguments, making it a very useful function. Let's get started with a simple example where we'll calculate commission amount based on sales value. We have a table with columns for salesperson name, sales value, and commission amount, where we'll use our formula. Right above this table, we have different commission rates based on sales value. Salesperson with sales value less than $5,000 gets no commission. Sales value between $5,000 and $10,000 gets 5% commission. And finally, sales value greater than $10,000 gets 7% commission. Our goal here is to calculate the commission amount for each salesperson based on their sales value. Let's get started. Type in equal sign IFS, press tab. This function takes two minimum arguments, logical test and value if true, where logical test is the condition that the function evaluates and value if true is the result that the function returns. Under logical test 1, we would like to determine if the sales value is below 5,000. So select the sales value, type in less than sign 5,000, comma. Now select the cell containing the text no commission and press F4 to lock it, as we will send the formula down, comma. So our first logical test will be that when the sales value is below $5,000, it will return no commission. This is the first condition that the function will check. All right, next, select the sales value again, then type in the less than and equal sign and 10,000. Type a comma, proceed to the next part. Now, when the sales value is below or equal to 10,000, we need to multiply the sales value by the corresponding commission rate. So select the sales value, type in asterisk, and then select the correct commission rate and press F4 to lock it. Type comma. Finally, if none of these conditions are met, then the amount must be more than $10,000. And for that, the commission rate is 7%. So under logical test, we will type the true function, which will always evaluate to true, comma. Now select the sales value and multiply it by the corresponding commission rate. Press F4 to lock it. This will ensure that the formula returns a value even if the previous conditions are not met. Close parenthesis, control, enter. Let's verify the result of the first line item. The sales value is more than $10,000, so the commission rate will be 7%. As you can see, our formula has worked correctly. For the next line item, the sales value is 5,000, so 5% of 5,000 is 250. For any sales value below $5,000, no commission has been assigned. To summarize, the IFS function is a very straightforward way of checking a list of conditions in sequence and returning corresponding values. Next, we are going to learn how to assign letter grades based on numerical scores using both IFS and the new switch function. Here, we have a data set containing numerical values. Our goal here is to assign a letter grade to a number based on the grading scale. Let's start with the IFS function. Type in equal sign IFS, press tab, select the cell containing the score, type greater than sign 89, comma. Now, if this logical test is true, we want the letter A. So type in letter A within double quotes. This is the first condition that the function will check. If this is not met, it will proceed to the next condition. Now, select the cell again, type in greater than sign 79, comma. If this condition is met, we want B, comma. Under logical test 3, we will do the same. Select the cell greater than sign 69. If this is the case, then we want C. Next, if this value is more than 59, then we want B. Finally, type in true, press tab, comma, F within double quotes. So, if none of the previous conditions are met, which means if the score is 59 or below, then F will be assigned. Now close parenthesis, control enter. Now double click the fill handle and send it down. Now, as you can see, all these scores have been converted to their respective letter grades using the IFS function. Next, we'll achieve the same result using the switch function. The switch function evaluates an expression against a list of values and returns the result corresponding to the first match. It's often used for replacing the IFS function or multiple nested if statements. So type in equal sign, switch, press tab. The first argument is expression, which is the expression you want to evaluate. We will set this to true, which means that the function will evaluate each condition in the list to see if it's true. Comma, next, we will set our conditions just like the IFS function. Under value 1, select the cell containing the score, type greater than sign 89, comma, type in A within double quotes. Type a comma. Now, this is the first condition that the function will check. If this is not met, it will proceed to the next condition. So our next condition will be if we will check if this value is more than 79, just like the IFS function. If that is the case, then we want B. We'll do the same for the rest. Now, if this value is more than 59, we want B. And finally, we will type in F as our default value. So if none of these conditions are met, then it will simply return F. Press Ctrl Enter. Double click the fill handle and send it down. As you can see, both functions have returned the same results. By using the switch function with true as the expression, we are effectively creating a series of if, then, else statements in a more compact form, making the formula easier to read and manage. Next, let's check out some more examples of the switch function. In this example, we will use the switch function to assign employment statuses based on numeric codes. Let's start by looking at our data set. We have a table with salesperson names and numeric codes in the next column representing their employment status. We want to convert these codes into clear text labels, full-time, part-time, etc. Right on top of this table, you can see what the numeric codes represent. 1 for full-time, 2 for part-time, 3 for contract, and so on. Finally, if none of the employment statuses match, if it is not found, then we need the description unknown status. Let's get started. Type in equal sign, switch, press tab. Under expression, select the cell containing the numeric code you want to evaluate. Comma. Now type 1 under value, comma. If the employment status is 1, then the result should be full-time. So type in full-time within double quotes, comma. Now type in 2, comma, part-time. Then type in 3, comma, contract, comma 4, comma intern. And finally, we will type in unknown status as our default description. Now close parenthesis for the switch function. Okay, so we forgot to close this with double quotes. All right, so press Control Enter. Now double click the fill handle and send it down. As you can see, the switch function has correctly translated each numeric code into the correct employment status. In the next example, we learn how to look up product codes by product name using the switch function. I'll also explain why it can be a great alternative to the VLOOKUP function for smaller data sets. Here, we have a list of product names and we want to find the corresponding product codes. By changing the product name in this cell, the result should update automatically. Since this is a small data set and the product information rarely changes, we don't want to use VLOOKUP. Now, you might think that manually entering all the product names and their codes into the switch function, even for a small data set like this one, will be time consuming and prone to errors. That's why we will use text functions to simplify this process. In our third lesson, we covered text functions. We'll use text join and value to text to streamline our formula. So let's get started. Type in equal sign, text join. Our delimiter will be a comma, ignore empty true. Now we will use the value to text function. Under values, we will select all the product names along with the product code. The format will be strict. Close parenthesis for both functions. Press Control Enter. As you can see, using these text functions, we have all our data within double quotes separated by a comma in a single cell, just the way we need it for the switch function. Now copy this function and paste it right below it using Alt H VV. So we'll paste only values. Now copy the values to the clipboard. Alright, now let's type in our switch function. Type in equal sign, switch, press tab. Under expression, select the cell containing the product name you're looking up. Comma. Now paste what we had copied earlier. Now close parenthesis for the switch function and press Control Enter. As you can see, the switch function has correctly translated motor graders to the corresponding product code. Let's change the product name and see if the product code updates. So for drills, it is DRI 336. DRI 336. Great. With VLOOKUP, you would need to create a separate table like this somewhere in your spreadsheet and reference it in your formula. However, with the switch function, all the values and their corresponding results are contained within the function itself, making it easier to manage and understand. To summarize, the switch function is particularly useful for scenarios where you have a fixed list of values and you want a simple and clear way to map these values to their corresponding results directly within the formula. Next, we'll take the switch function to a new level by using functions within its expression. In this example, we'll calculate gross profit based on product categories and sales data. We have a table with product codes, sales values, and desired gross profit calculations. We also have a separate table listing product categories along with their corresponding gross profit margins. Our goal in this example is to first extract the category code from the product code column and then match it with the corresponding GP margin to calculate the gross profit. As you can see from this table, BS is the category code for beverages, BAK for bakery, and MT for meat. Let's get started by typing in the switch function. Under expression, we will use the left function to extract the category code from the product code column. So under text, select the product code, comma. Under number of characters, we will use the find function to locate the position of the hyphen within the text string. Now close parenthesis for the find function. Now subtract 1 from the result to get rid of the hyphen itself. Now close parenthesis for the left function. Type comma, move to the next part. All right. So now, based on this expression, we want the following results. So first for BS or beverages, we want 0.35 or 35% of 1. Next, for BAK, we want 0.45. Next, for MT, we want 0.55. Now, close parenthesis for the switch function. Press Ctrl Enter. Now this returns the correct GP margin for the category code of the first line item, which is BAK for bakery. Now, in order to calculate the gross profit, we will simply multiply this with the sales value. Let's verify the answer for the first line item. The category code is BAK, so it's 45%. So let's check this. Next, it's MT, so this time it's 55%. So as you can see, our formula has worked correctly. To summarize, using the switch function with an expression is a powerful way to simplify our calculations, especially when dealing with multiple categories and corresponding values. This method reduces the need for complex nested if statements or additional lookup tables. Let's proceed to the next part. In this final portion of the lesson, we'll explore some complex examples using the IFS function along with a bunch of other functions which we have already covered in our previous lessons. Let's get started. In this example, we'll learn how to convert various pay formats into standardized numerical values for easier analysis. Let's take a look at our data set first. We have employee names and their corresponding annual salaries. Our goal here is to convert the values in the annual salary column into a standardized numerical format. For example, for the first line item, the answer should show 862710 without the K for 1000 or M for million at the end. And for those which do not have a unit indicator at the end, we want the function to return the value as it is. As always, we'll break this complex formula into smaller parts for better understanding. Let's start by extracting the unit indicator. We will use the write function. So type in equal sign, write, press tab. Under text, select the cell containing the annual salary, comma 1, press Ctrl Enter. Now double click the fill handle and send it down. Now with the help of this, we will separate the numeric part. First, copy the right function. Open equal sign, left, press tab. Under text, select the cell containing the annual salary, comma. Now we will use the find function to locate the position of the unit indicator. Under find text, paste the right function as we are looking for the unit indicator. Next, we are looking for the unit in this cell. Now, close parenthesis. Now type -1 at the end to exclude the unit indicator itself. Close parenthesis. Control Enter. Double click the fill handle and send it down. Now we will use the IFS function to convert the extracted numeric value based on the unit indicator. Let's understand it in a very simple way first. Type an equal sign, IFS, press tab. Under logical test 1, we would like to check whether the unit indicator is M. So select the cell containing the unit indicator, type in equal sign. Now within double quotes, type in M. This will check if the indicator is M. If it is, then we would like to multiply the numeric part by 1 million. 1 followed by 6 zeros. Type comma to move to the next one. Next, we'll check if the unit indicator is K. Within double quotes, type K. Now, if this is true, we would like to multiply the numeric part by 1000. Finally, if none of these conditions match, then we want the function to return the value as it is. So type in true, comma. Now select the cell containing the annual salary. Now close parenthesis for the IFS function. Control Enter. Double click the fill handle and send it down. As you can see, we have successfully converted different pay formats into numerical values. Now let's achieve the same result with a single formula using nested functions so that we can get rid of these extra columns. First, open the clipboard pane and copy both formulas to the clipboard. Now equal sign, type in equal sign, IFS, press tab. Under logical test 1, paste the right function containing the unit indicator, type equal sign, M within double quotes, comma. Now, if this is true, we want to multiply the numeric part by 1 million. Next, we'll check if the numeric part is equal to K. If that is the case, then we will multiply the numeric part by 1000. Next, if none of these are true, then just return the value in this cell. Now close parenthesis for the IFS function, press Ctrl Enter. Now we will enclose this entire formula within the dollar function, as we need the currency format, and we will set the decimals to 0. Close parenthesis, Control Enter. Now double click the fill handle and send the formula down. So as you can see, we have successfully achieved the same result using a single nested formula this time. Now you can easily perform calculations and analysis on your data. And there you have it. We have effectively transformed different pay formats into standardized numerical values. By combining text functions and logical functions, you can handle various salary formats with ease. This technique can be incredibly useful for financial data analysis, ensuring consistency and accuracy in your calculations. Next, let's check out another complex example where we will do the opposite. This time, we will transform numerical values into easy to read text with units like B for billions, M for millions, and A for thousands. This is especially useful for simplifying large numbers for reports or presentations. Let's dive in. First, let's take a look at our data. We have a list of numerical values, and our goal here is to convert these numerical values into more readable text formats using a single formula. We'll use the IFS and text functions to convert these numbers. The IFS function will help us define multiple conditions, and the text function will format the numbers appropriately. All right, so type in equal sign IFS, press tab. First, we will check if the number is in billions. So select the cell containing the value, type greater than equal sign, and now type in 1 billion, which is 1 followed by 9 zeros, comma. Now we will use the text function to format the value for readability. So type in text, press tab. Under value, select the cell containing the value and now divide it by 1 billion, comma. Now type the format code defining how to display the number. Type 0.000 for 3 decimal places within double quotes. Now close parenthesis for the text function. Now we'll concatenate the formatted number with the corresponding unit, which is B for billion. So type in ampersand and within double quotes type in B. Type comma. Next, we will check if the number is in millions. So select the cell containing the value, type in equals, type in greater than sign, equal sign, and now type in 1 million, which is 1 followed by 6 zeros, comma. Now once again we will use the text function. Now this time we will divide the value by 1 million, comma, and we will format this to 1 decimal place. Close parenthesis for the text function, and now we will append the letter M at the end using ampersand. Now type a comma, move to the next logical test. This time we will check if the number is in thousands. So select the cell, type in greater than sign, equal sign, 1000, comma. Now type in the text function once again, select the value and divide it by 1000, comma. We will format this as one decimal place, close parenthesis for the text function. Type in ampersand and append the letter A at the end within double quotes. Now type a comma, move to the fourth logical test. Now finally, if none of these conditions are true, we want the function to return the value as it is. So type in true, comma. Now select the cell containing the value. Close parenthesis for the IFS function. And press Ctrl Enter. Now double click the fill handle and send it down. Now what we can do is we can add line breaks so that this is much more easier to read. So as you can see, we have successfully converted large numbers into more readable formats using the IFS function combined with the text function. This comprehensive approach ensures that any numerical value is presented in the appropriate text format. Now, interestingly, you can achieve the same with custom number format to display large numbers in a more readable format by converting them into millions and thousands. The format is right here in this cell. Apply this directly to cells to change the appearance of numbers without altering their underlying values. This format is excellent for simplifying the display of large numbers up to millions. However, please note that it does not extend to billions. So this concludes our lesson on logical functions, which are powerful tools that enable users to make data-driven decisions and automate complex calculations. If you have any questions or need further clarification, please leave a comment below and we'll be happy to help. Don't forget to like and share our tutorials with your friends and colleagues, and also make sure to subscribe to our channel for more in-depth tutorials. Thank you for watching and happy excelling.